one more, guys. Just one more. One more math class this week. I forgot to tell you yesterday on Wednesday that your homework is not due, but it would be due today. Okay? Today on Thursday, that's 2 days after it was first assigned, on Tuesday through your syllabus, that your homework is due today. And so by the end of the day, you need either to email that to me, and obviously we're not using like mail to me. I mean, you can if you want, but don't worry about doing that. Just scan it if you have a scanner. That works excellent. If you want to take a picture of it, if that's easier, and you can send it as a messenger, Facebook Messenger attachment. You can send it as an email attachment, or you can just text it to me as well. All three of those things work, but please do get that homework to me if you will. Also, your second quiz as homework in math, obviously that's the class that we're in, but is assigned today. So you'll have two class periods, so it's not going to be due next Monday when you get back, but it will be due next Tuesday. So just a heads up on that. Well, what we're going to be doing today, and you guys know how I shoot straight with you, I'm just going to let you know right now that what we're doing today is not extremely easy. After a little bit, I don't think it's going to be extremely difficult either. But make sure that you give some time and attention to it, and especially make sure you pay close attention in the video, and make sure that you take down good notes, not only to be able to do your homework, but also then to do your test. And two, it just helps to get it drilled into your mind what it is that we're doing. So without further ado, here we are. You're going to recall, I hope anyway, here a chapter or two back, and I believe it was last chapter, that we dealt with when you have factors, turning those into squares. And remember when we showed the shortcuts of those, how we do that? You can take what are called conjugates, okay? If you have the terms A and B, and they're the same thing, A here on the left side, B here on the right side of both of those parentheses that are factors are being multiplied together, and the only difference between them is a positive sign and a minus sign. Those are called conjugates. They're almost the same thing, but the only thing that separates them is a sign. And we use those to turn that information into what's called the difference of squares. I know that's pretty small. This is probably a little bit more legible, but that's the difference, abbreviated, of squares. And what it is you just take the A term in either one and you square it. You take the B term in either one and you square it, and you have a minus sign between, and you've turned that conjugate factor into the difference of squares, or squared form. In other words, you FOILed it out, but without foiling it. Remember that class when we taught the shortcut? And then Carter and I, we worked on the crazy cube rule too, which is a lot of fun as well. Well, we're going to be doing the same thing, except we're going to be doing it in reverse order. Instead of taking the conjugates and turning them into squares, we're going to be taking the squares and turning them back into their conjugates. In other words, what we're doing is we're factoring, but we're not doing it the old-fashioned hard, slow way. We're doing it the newer, quick way. And so from x squared minus 49, what I'm going to do, and I made this mistake yesterday, I don't intend to make it twice. I'm going to change colors here so that it shows up a little bit better below. And what I'm going to go ahead and do is put two parentheses, okay? Two parentheses, and in those parentheses, we are going to have our A term, which is x, okay? And then we're going to have our second term, and look, I have a perfect square in my first term, or I'm sorry, not a perfect square, but I have the difference of squares in these two terms right here. And this one is an x, or a variable squared, and this one is a negative 49, okay? And there's something that was squared, okay, to get to that 49 number, not the negative part of it, but to the 49 number itself. And so really what I'm going to do to determine what's found inside of each one of these parentheses, remember, based on the rule, the difference of squares, whenever I have two perfect squares, whenever I turn them into factored form, one's going to be a positive and 1's going to be a negative as far as what comes, the number that comes after that x. And guys, basically all that I'm doing right here is I'm just taking the square root of everything that's up there, which is just two terms. What's the square root of x? The square, or x squared, the square root of x squared is x. And that's why I write x in each one. Guys, this is so easy. What's the square root of 49? In other words, what times itself is a number that will get you to the number 49? 7 times 7. And therefore, I just write 7 in each one of those blanks. Now that's easy. That's a shortcut. And the only thing you really do is just take the square root of each individual term to get to that point. But when you have the difference of two squares, two squared numbers, which is what we have right here, and right here, this all corresponds with this side. This is our formula for the shortcut. You're going to have the conjugates, or a plus b times a minus b. Alright? Now let me show you why this works mathematically. Now I'm only going to do this on the first one, and I'm not going to waste your time and do it on all the rest of them. I will one over here when we switch rules. But for these three, I'm just going to give you one example. Remember, when we don't have a coefficient that's greater than 1 in front of the first term, alright, we look to the last term and we ask ourselves, what are two factors of negative 49? What are two factors of negative 49 that when added together make our middle term, which, look, where's our x term? There isn't one, which means x must be 0, 0x, because there isn't a term in the middle. So what are two factors of negative 49 that when added together make 0? Let me think. It has to be a negative, so one has to be negative, one has to be positive. How about negative 7 times 7? Negative 7 times 7 is negative 49, but remember, when added together equals 0, which is the middle term that's not there, 0x. What's negative 7 plus 7? 0. And so we're actually following the same formula that we've done in almost all the others and the easiest ones. But what you can do is use the difference of square rule to bypass and just very quickly do that math. And so on these easier ones, if you struggle with that like we did in that last chapter, you can still go about it the longer old-fashioned way. But this whole section, this whole sub-unit here is on these special patterns and the shortcut rules, and that's why I'm going to teach it. Okay, how about number 2? Let's do the shortcut for this one. How do I start out? The first thing I need to ask myself when factoring is there anything in common that I can factor out to make the equation simpler? Does 5 have anything in common with negative 125x squared? Well, the variables aren't in common because this one doesn't have a variable, but what they do have in common is a number. And that number is the first one that you see, 5. We don't have to turn around the order on this one. In fact, it's going to work better if we just leave it in the order in which we were given it. But we are going to factor out 5. We are going to factor out 5 from all this, which means we're going to divide each of these terms on top by the number 5. What's 5 divided by 5? That's 1. Let's put our minus sign in so we don't have to worry about negatives and we can just do the simple math. What's 125 divided by 5? Well, that's maybe not extremely easy. It actually is. One way, we'll go look at it the harder way to make sure we're all on the same page here. How many times does 5 go into 12? Twice, as far as evenly, or as evenly as it can. Okay, so it's going to go in twice, right? And you're going to have a remainder of 2. Okay, 12 minus 10 is 2. Bring down your 5. 25 is what you have remaining. How many times does 5 go into 25? 5 goes into 25 5 times. Okay, don't forget your x squared that's still there. Close your parentheses. Okay, I made it simpler in factoring out a 5 from both terms. Now I just keep that 5 as I go on. Remember how we did that before? Just keep that 5 as I work through. But we're going to take the shortcut rule, and here's why. I have the difference of two terms that are perfect squares. I'm going to leave my 5 I'm going to make 2 parentheses, and I'm going to leave my terms in the order that they're found. And basically all that I'm going to be doing here, guys, is taking, I think the easiest way to look at it is the square root of both terms to figure out what goes where. This one's going to go first in both places. This one's going to go second in both places. All right, your A term and your B term. So, what is the square root of 1? The square root of 1 is 1. I love square rooting 1. I love squaring 1 because it does not change. And so my A, or my first term, is going to be the same per my rule in both parentheses. Now look, in order for my rule to work, I have to have a plus sign in one of them, and I have to have a negative sign in the other. So I'm going to do a plus here, I'm going to do a negative there. Now, what is the square root, first of all, of the number 25? In other words, what number times itself gets you to 25? That's the square root. Well, the number times itself that gets you to 25 is 5. And so I'm going to write that in both spots. And don't forget, though, I have to also take the square root of the variable. X squared. What x with an exponent times itself gets you to x squared? Well, when you multiply x, or when you multiply variables with exponents, remember you add their exponents. And so that would be x, because x times x gets me x squared. And so the square root of x squared is just an x. And so that's what I write in each one. Now, isn't that cool? You start out with something big, you factor something out, and you wonder, where do I go from here? Guys, use that shortcut rule. It really makes it, especially once you get used to it, makes it go just like that. If you didn't have and you couldn't remember the formulas, it wouldn't do you any good. But I'm letting you write down the formulas. Obviously, you can always use them for your homework, but I'm letting you write down those formulas so you can also use them for the test. So take advantage of that leniency. All right, let's do one that I think is going to be a lot of fun, because there are 3 different variables in this one, but we're still going to use the rule of the difference of squares to break it down into its factored form. Our equation is 36x to the 6th power, z to the 2nd power, minus 64 y squared. The first thing I need to ask myself is, do either of these terms have anything in common that I could factor out from the very beginning? Well, this one has a y, this one doesn't. This one has x and z values, this one has neither. So I can't do anything with variables. But how about 36 and negative 64? Do they have anything in common? Well, if you look at them, they're both even numbers, so yeah, we know that would at least work, the number 2, that is. What about 3? Well, I can tell just like that, as in, that 3 will go into 3 and 3 will go into 6, so yeah, it works for that one. 3 will go into 6, but 3 doesn't go into 4. That's not going to work. How about the number 4? Well, let's try that one. Let's try to bring factor 4 out of each one of these binomials. Okay? So we have 4, and we're going to divide 4. Let me write that just a little bit smaller, so hopefully I don't run out of room. We're going to divide 4 into 36. So what's 36 divided by 4? It's not 8, although it's close. That would be 32 if the answer were 8. But 36 divided by 4 is 9. Remember, I do nothing with the variables, so I just bring those down. X to the 6th power, z to the 2nd. Okay, what is negative 60? Well, let's just write the minus so we don't have to worry about the negative. What's 64 divided by 4? 4 goes into 6 one time in its fullness, okay, with a leftover of 2, but then you have to bring the 4 down, so you have 24 remaining after 4's gone in once. How many times does 4 go into 24? That's a total of 6 times, and so your number's 16. Minus 16, just bring down your variable with its exponent because there's nothing yet that you can do with that. Now here's why I've done what I have. If you'll notice, guys, I have, just ignore the 4 even though it's mathematically attached, but outside of that 4 right there, and actually it is too, But what's inside of the parentheses, I now have a perfect square. I keep saying perfect square. I have a difference of squares. Technically there's a difference. But both of these are perfect squares of themselves, these numbers, and that's what I mean. 9 is a perfect square. 16 is a perfect square. And so I can use the difference of square rules now that I'm in this reduced form, and actually I could have in a bigger form up here. But now that I'm in this reduced form, I can use the difference of squares formula in which I'm going to break down this first term and this second one. Rewrite your 4. Make yourself 2 a little more sizable parentheses. Okay? Make yourself 2 a little more sizable parentheses. Now the first term, a. And what I'm going to do is just essentially take the square root of both of these terms. What's the square root of 9? Or in other words, what times itself is a factor of 9? What times itself gets me to the number 9? Well, of course, that's 3. Because 3 times 3 is 9. Now, here's where it gets a little bit tricky. Alright, I'm going to take the square root of 6, the square root of z squared, the square root of y squared. We haven't dealt with anything more than a square. Let me show you something just really quickly once. It's not going to correspond with 4. I'm going to erase it, but I have room over here. If I have z to the 3rd power, okay, and I square that, z to the 3rd power, and I square that, what do I have in the end? Now remember, this isn't multiplying, okay? This is raising to a power. And now if I were multiplying variables with exponents, I would add the exponents. But whenever I raise an exponent to another power, that's when I multiply the exponents themselves, right? And so I end up not with x to the 5th power, but x to the 6th because I'm raising to a power. Now let me show you something. The inverse, or the opposite operation of squaring something, is square rooting it. Okay, square rooting it. And so if I have x to the 6th power, what am I doing when I place it under a square root? Up here, I multiplied by 2. If I'm taking the square root, what do you think I'm doing involving 2 with my original exponent? Guys, when I square root a variable with an exponent, I divide it by 2. We have never done that up to this point, okay? So that's a brand new concept. Make sure this example right here is included in your notes. And so the square root, on this one, the square of x to the 3rd raised to the 2nd power is x to the 6th. Well, on this one, if I have x to the 6th power and I square root it, it means I divide that 6 by a 2, which is going to give me x to what power? 6 divided by 2 is 3. Okay, does that make sense? I hope so. Again, I know that's different. If you need to, pause the video. I'm going to erase it right now. But if you need to, pause the video, write this down, and don't go on with me until you understand that concept. Okay, I'm going to get rid of it in the live video to me, not so much to you. It's a dead video. But going down here now, back to number 3. Okay, I take this actual square root of the number, but the variables, they're different. I divide the variables by 2. So x to the 6th, square rooted means I divide it by 2, gives me x to the what? 6 divided by 2 is x to the 3rd power. And if I have z, okay, or I'm sorry, I have z squared and I square root it, that means I divide z squared by 2. What's 2 divided by 2? That's 1, or z to the 1st power. Okay, now guys, whatever I got for this first term, I don't just write it in the first parentheses factor, I also write exactly the same thing. So there's no math to do a second time in the second parentheses. And because of my shortcut rule, I put a plus sign after the first one and a minus sign after a second one. That's my formula. Now I square root the second term. What's the square root of 16? Or what times itself gets me to the number 16? That's the number 4. Because 4 times 4 is 16. But don't forget to square root your variable, which is y squared. And if I have y squared and I square root it, that means I divide that variable by 2. What's 2 divided by 2? Is 1. So in other words, y to the first power. And so I just write y, because I don't express the 1 in simplified form. And so my shortcut to this fairly complicated equation to find the factors of it is 4, and then in parentheses, 3x squared z plus 4y, close parentheses, open parentheses, 3x squared z minus 4y, because when I have the difference of squares, my formula is to turn that in conjugate form. In other words, I have the same first term, the same last term, but I have a difference of sign in the middle. One's a plus and one's a minus. Okay, now I think these may be even a little bit easier than what these are. Do you recall the rules for truly perfect squares? The way we did this was, if I have, the way we did it was if I have this over here, this squared, I can FOIL it out into this term. We're looking at it from the reverse angle. If I have it already FOILed out, I can put it back into factored form. But look, if I have a perfect square on the front and a perfect square on the end and a middle term that's positive, then that means I'm going to have the same factor in parentheses twice, but I don't write it out 2 different times. I just write it out once and slap a squared on the top right. Okay? But if I have a perfect square in the front and a perfect square on the end, but I have a negative term in the middle, I still am going to have just a single parentheses with the squared in the top right, but the difference is if there's a minus as the middle term, there's going to be a minus in the middle between these 2 terms whenever they're factored. That probably doesn't mean a lot right now, but let me show you an example and then I know it's going to make perfect sense. Okay, I have x squared plus 10x plus 25. The first thing I do is look, do I have a perfect square on the front side? The answer is yes. X squared, that's x times x. Do I have a perfect square on the end is the third term, 25? Yes, that's 5 times 5. Now I need to look, I have a middle term, and is it positive or is it negative? It's positive. And therefore I'm going to use my first rule, okay, my first rule right up here. If I have a perfect square on the front, a perfect square on the end, and a positive term for the third of my trinomials in the middle, then here is the formula that I'm going to use. Just a single parentheses, a plus in the middle, and it's going to be squared. Now watch, I'm telling you, I know it sounds complicated right now, but it's as easy as pie, and then I'll show you the old-fashioned way as to why this is mathematically sound. Okay, look, all I have to do for absolute perfect squares is to square root the first term and square root the last term. Okay? What is the square root of x squared? In other words, whenever we do variables with exponents, we divide the exponent by 2. What's 2? We keep the exponent, but what's 2, or x to the second power, what's 2 divided by 2? That's 1. And because I don't express that as an exponent, it's just understood, I simply write x. In other words, x times x gets me to x squared. Therefore, the square root of x squared is simply x. Now on this end, what's the square root of 25? What I'm asking is, what times itself gets me to the number 25? And that's the number 5. Because 5 times 5 is 25. Guys, look, I'm done. Isn't that cool that if you understand the rule and the formula for perfect squares, it's fast. Now look, don't sweat it if you think this is just too much, that's too complex. You can still go about this the old-fashioned way and come up with the right answer. And let me show you how. Now remember how we do these? If the coefficient's not greater than 1, or the number in front of the x squared isn't greater than 1, as it's understood to be right here, okay, original equation, I just look at the last term, the third one, 25. And then from there I look at the middle term. And I say, what 2 factors of 25 when added together, get me to a positive 10? What two factors, this is the old-fashioned way, what two factors of 25 when added together get me to positive 10? And the answer is 5 times 5. Because 5 times 5 is 25, but 5 plus 5 added together is 10. And so do you remember what we do as our rule then? We just write x at the beginning of each one of our parentheses, and then we just add it, we just slap on an x to each one of these terms that when added together equals that, because there is a 10, not just 10, but a 10x in the middle. Remember our doing this the last couple of class periods? And so what we'd have is x plus 5 and x plus 5. Okay, understood when they're FOILed out, they're going to get those x's reattached to combine to make 10x. So remember our doing that from this, but how can that be simplified? X plus 5 times x plus 5. Guys, that can be simplified as x plus 5 squared. Does that look familiar? So you see, I can go through that longer drawn out process, or I can learn the rules of perfect squares and just look at it and be done like that. And really it's just, our choice as to what we prefer. Okay, number 5. There is a coefficient or a number in front of the first term x squared that's larger than 1. So what I need to do is ask myself, can I factor out anything common from these three terms? And the answer is yes, I may do so. And what I can pull out of all three of these, now they all three don't have variables, but they all three do have a number in common as a product. The factor is the number 3. And so I'm going to pull out a 3 out of each term. I'm going to leave the variables for those that have it, terms that have it, where they are, because there's no variable I'm taking out, but I'm pulling out the common factor of 3, the greatest common factor. What's 12 divided by 3? 12 divided by 3 is 4. Okay, keep your x squared. What is, I'm going to put my minus so I don't have to worry about negative numbers. What's 36 divided by 3? Well, 3 goes into 3 one time, 3 goes into 6 two times. Okay, so don't forget your x. Alright, and then lastly, how many times does 3 go into 27? It's common multiplication table like the last couple, and that's going to be a positive 9. Alright, 3 goes into 27 9 times. Now, this really speeds these up. Bring your 3 down, okay, but ask yourself, is 4 a perfect square? Yes. Is x squared a perfect square? Yes. Is 9 a perfect square? Yes. Is the term in the middle a positive or a negative? And it is a negative. And therefore, I have a perfect square rule that I can follow as a shortcut to get me to an answer just like that. And what it is I'm going to have a number, or a term I should say, in the front. And because the middle number is negative, I'm going to have a minus sign after that term in the middle. I'm going to close the parentheses, and then I'm going to square the entire thing. And guys, to figure out what goes in those two spots, listen to me, this is all that you have to do. Just square root the first term and square root the last, or the third term. First term is going to go there, the last term is going to go right there. Okay, what's the square root of 4? Or what times itself gets me to the number 4? That's the number 2. Now what's the square root of x squared? And remember, that means I take the variable of the exponent and I divide it by 2. What's 2 divided by 2? 1, or in other words, it's just going to be x. Okay? So 2x is my first term when I take the square root of it. For my last term, what is the square root of 9? What times itself gets me to 9? 3. Isn't that awesome? And so you don't have to go through that whole long drawn out process where I have 2 terms here, 2 terms here, factor something out. But listen, If this is too much and this is too difficult, you can go through it and you can still do it the old-fashioned way, and you're going to come up with exactly the same answer, just like we did up here, just like we did on this one up here. You can do it that way, but I'm just teaching you the shortcut if you prefer to do it that way. And part of the reason I teach the shortcut is because you get to one like this, and it gets really difficult to do if you don't take the shortcut. Now, this one does not have a coefficient or a number in front of it that we see, this x to the 6th and the y to the 4th. However, isn't there understood to be a number in front of it? What is that number that's invisible right here in front of that x to the 6th as well as y to the 4th? What's the number in front, guys? It's the number 1, but because it's redundant, it's not written. That is very important. Okay. Is the number 1 a perfect square? Yeah, it's not a large one, but it is a perfect square. Is 16 a perfect square? Yes, it is. And therefore, we can use the formula for the shortcut of a perfect square to come up with an answer just like that. And here's the way we do it. I need to look at the middle term. Is it positive or negative? There's a negative sign, and therefore, I'm going to use the formula that has a subtraction sign in the middle, because the middle term has a subtraction sign, and that's my formula for it. Don't forget, I'm going to square that at the end. Now guys, all I have to do on this one is just take the square root of the first term and the square root of the last term. The square root of the first term goes here, the square root of the last term goes right here. The square root of 1 is obviously 1, and just like as it was from the start, I'm not going to write that in because it's unnecessary. But I do need to take the square root of x to the 6th. What is the square root of x to the 6th power? Remember, when I take the square root of a variable with an exponent, I divide the exponent by 2. Just like if I were squaring it, I would multiply the exponent by 2. If I'm taking the square root, I divide the exponent by 2. What is 6 divided by 2? That is 3. And therefore, I have x to the 3rd power. Don't forget, you have to do it with the y also. What's the square root of y to the 4th power? Y to the 4th power means I divide the exponent of 4 by what number? By 2, the square root. 4 divided by 2 is 2, or squared. And so I'm going to have x cubed y squared as my first term. I have that subtraction sign in the middle because that's what my formula is when my middle term is negative. And what is the square root of the number 16? What times itself gets me to 16? Number 4. And so that's my coefficient, or my number, in front of the variable. I also have to take the square root of z squared. What is 2 divided by 2? That's what I do with the exponents of variables when I square root them. 2 divided by 2 is 1. So I'm still going to have a z, but it's only going to be to the first power. And because it's to the first power, I don't write that 1. And guys, how cool is that? That's the shortcut to that big, long joker. Thanks to knowing what the formulas for the difference of squares and the perfection of squares truly are. And that's our math lesson for the day. And guys, that is math for the week. And I know this is a little, and it was like that the last chapter, I know this is a little bit of a challenging one, and you don't have to do it this way, but man, if you can, it makes math, and especially this stuff that we're doing, a whole lot easier. Alright guys, I'm going to leave you with that, and I'm going to let you enjoy your 3-day weekend. Thanks for all of your hard work. Get done any work that you need to complete, but at the same time, once you get it done, relax a little bit, give your brain a break, and we'll come back and we'll tackle things together next week. Have a great weekend, guys.